All right, this next video is going to be just a little bit more on vectors. It's more than the introduction that we had previously. So the first thing that we're going to talk about is the unit vector. So there are a few things to know about the unit vector. First, it's a unit, and so the unit vector has a length of 1. And then second, the way that you write the unit vector is by taking the component form and dividing it by the magnitude. So we're going to write the unit vector by dividing the component form by the magnitude, which kind of makes sense, right? So if you have a unit vector, it has a horizontal component and a vertical component already, and if you take that and divide it by the overall length, it's going to shrink it down and make it a length of 1. So the way that we're going to write this is we're going to say that a unit vector is the vector, original vector, divided by its magnitude. And so the way we're going to think of that is the first piece divided by and then the second piece divided by the magnitude. And we're going to go ahead and write it like that. So for example, if it says to find a unit vector in the direction of v equals -3, 2, so there's our vector, then what we're going to do first is we're going to go ahead and find the magnitude because we need that so we can divide by it. So this is the square root of -3 squared plus 2 squared. And so that's 9 plus 4. So the magnitude here is the square root of 13. So then we're going to say that the unit vector is going to be -3 divided by square root 13 and 2 divided by square root 13. And of course, we have to fix the denominator. We have to rationalize it because we're not allowed to leave square roots on the bottom of a fraction like that. So we'll go ahead and fix the first one and fix the second one. And so the unit vector here is -3 square root 13 over 13, and then 2 square root 13 over 13. So you'll notice if you were to draw a picture of this, the slant would be the same, but the vector would be considerably shorter because now it would be a length of 1. All right, we're going to learn another notation. And this one, I believe, is just a little bit more common. Typically, when we write vectors, we write them this way. For like our answers, we typically write them this way. So this is AI plus BJ form. And the I, like let's say I had a vector that was just plain old I. That would mean the vector was 1, 0. And so the A value is basically, the coefficient for the I is basically whatever number you would have had in that first spot. And so that number is the horizontal component. And then if you had a vector that was just plain J, then they really meant 0, 1, and that's the vertical component. So basically, the numbers that were in your original vector inside those little V-shaped things, the A and the B, those coefficients are actually the exact same numbers. So if the component form of a vector was written as -1, -2, then we could write that as the vector equals -I minus 2j. All right, so now we're going to do another example. We're going to say find the unit vector of u equals 2, -5, and write it in the form AI plus BJ. So first, to be able to write the unit vector, we have to find the magnitude of u. And so that's going to be the square root of 2 squared plus negative 5 squared. And so that's 4 plus 25, which gives you 29. All right, so if we go ahead and write that out, then that's going to be 2 divided by square root 29, and negative 5 divided by square root 29. And then we have to rationalize it, just like we did before. And so that leaves us with 2 square root 29 over 29, and negative 5 square root 29 over 29. And so now if I write this in AI plus BJ form, then it's going to be 2 square root 29 over 29i minus, because that was a negative number, and then 5 square root 29 over 29j. All right, next we're going to do some algebraic operations with these. And I'm not going to give you like a list of things to think about. I'm just going to say, like, this is going to work out about as you'd expect based on your math history. But one little hint is to think of like terms. So the i's will be like the i's and the j's will be like the j's. So we're going to go ahead and perform the operations for different problems, and we're going to use vector v, which is 2i plus 3j, and we're going to use vector w, which is 3i minus 4j, and then we're going to go ahead and find various things with those. So the first thing we're going to do is v plus w. And so if you're doing v plus w, then you have 2i plus 3j, and you're adding that to 3i minus 4j. And so here we're just going to combine like terms. So we have 2i and 3i makes 5i, and then we have 3j and negative 4j makes negative 1j, and that's our answer. So the vector v plus w would equal those together. If we have v minus w, then we're going to set the problem up in a very similar fashion. We're just going to be subtracting them. So I'm going to go ahead and distribute the negative. You're welcome to do the subtraction in your head if you want, but students typically do things incorrectly, I find. So I went ahead and distributed the negative, and so now I can combine like terms. So I have 2i and negative 3i makes negative I. And then I have 3j and 4j, which makes 7j. Let's say I want to do 3 times vector v. Then I'm going to have 3 times 2i plus 3j. So I can just go ahead and distribute that 3. So that gives me 6i plus 9j. Let's say I wanted to do 2v minus 3w, then I could just write 2 times 2i plus 3j minus 3 times, I don't remember what it was, 3i minus 4j. And then we can distribute those. So we've got 4i plus 6j and negative 9i plus 12j. And then again, we're just going to combine our like terms. So we have negative 5i plus 18j. So like I said, basically exactly what you would think of when you think of operations. That's how it works. So I also want to do a couple more that have to do with operations with the magnitude, because these are the ones that students tend to get wrong. So let's say we're saying the magnitude of v plus the magnitude of w. The magnitude of v is going to be the square root of 2 squared plus 3 squared. The magnitude of w is going to be the square root of 3 squared plus negative 4 squared. And so 2 squared plus 3 squared is 13, right? 4 plus 9 is 13. And 3 squared plus 4 squared, so that's 16 and 9, which is 25. So this is the square root of 25, which is just 5. And so I would say that these two magnitudes added together is the square root of 13 plus 5. But you might also have problems where it says, like, the magnitude of v plus w, and this is a different problem. To be able to do this problem, you have to know what v plus w is added together. So this was our v plus w, it was 5i minus j. So the magnitude of that is going to be the square root of 5 squared plus negative 1 squared, and that's going to be the square root of 26. So you'll notice that those two problems are different. One, you have to add the vectors together first and then find the magnitude. This one, you would find the magnitude separately and then add them together. Okay, one thing that is a little bit different than what you are expecting probably is vector multiplication. And when we do vector multiplication, we call it the dot product. And it's interesting because when you do the dot product, you're going to have a vector multiplied by a vector, and your final answer is going to be a single number, which is kind of the weird part about it. So here's how vector multiplication works. If you have vector v is a1i plus b1, that's a b1, b1j, and your w is a2i plus b2j. So the a1 and the b1 are coefficients for the first vector, the a2 and the b2 are coefficients for the second vector. Then the dot product, v dot w, or v times w, is going to be the horizontal components multiplied together plus the vertical components multiplied together. So a1 times a2 plus b1 times b2. So for example, if it says find v dot w if v equals 2i minus 3j and w equals 5i plus 3j, then to find v dot w, you're going to take the coefficients for I, so the horizontal component, 2 times 5, and you're going to be adding that to the coefficients for j, which is the vertical component, so negative 3 times 3. And so here we would have 10 plus negative 9, and so the dot product is just 1. And you'll notice even if you were to switch this and do w dot v, you would still be multiplying the a's together and adding them to the b's multiplied together, and so it doesn't matter which order you go. So here you would just have 5 times 2 plus, and then you would have positive 3 times negative 3, which obviously is going to give you the same thing. Now let's say we wanted to figure out what v dot v was. You're doing the dot product with the dot product of v with itself, so that would be 2 times 2, and then you would be adding negative 3 times negative 3, and you'll notice that if you multiply those together and then add, 4 plus 9 is 13. And you'll notice that that is actually very similar to the magnitude. If you wanted to find the magnitude of v, then you would be taking the square root of 2 squared plus negative 3 squared. And so if we look at this, if we were to square each side here, then we're going to say the dot product v dot v is the exact same as the magnitude squared. I guess you don't actually need those parentheses. Let me fix that. The magnitude squared. So the dot product of v with itself is the same as the magnitude squared. Okay, one last thing. We're going to look at the angle between two vectors. So here the formula is cos theta equals u dot v divided by the magnitude of u times the magnitude of v. All right, so for example, if we wanted to find the angle between vector u, which is 2I plus 3j, that's a j, and vector v, which is negative 2I plus 5j, then what that represents, if we were to draw a little sketch of this, 2I plus 3j would be like over here, so that's like that vector right there, and so that's the point 2, 3. And then negative 2, 5 would be like here-ish, so that's negative 2, 5. Then what we're really trying to find is this angle that's in between those. That's what theta would be. So that's what we're trying to find. So the first thing we would need to do is u dot v. And so that would be 2 times negative 2 plus 3 times 5. And so that's negative 4 plus 15. So u dot v is 11. We would also need the magnitude of u, and that's going to be the square root of 2 squared plus 3 squared. So 4 plus 9 is 13, so that's the square root of 13. And then we need the magnitude of v, which is the square root of negative 2 squared plus 5 squared, and that's the square root of 29. And so then we would plug all of those things into the formula. So we would say cos of the angle is u dot v, which is 11, over the square root of 13 times the square root of 29. And then if we wanted to solve for theta, all we have to do is get rid of the cos. And so we're going to do cos inverse on each side. Cos inverse. And so theta is cos inverse of 11 over square root of 13, square root of 29. And when you plug this in your calculator, you're going to have to be careful to make sure that you show your calculator that both of those things are on the bottom of the fraction being multiplied together. So just be careful when you plug it in. Since we're looking at a quadrant there, we're going to go ahead and make sure that we write our answer in degrees. And so be in degrees when you do this in your calculator. And you should get 55.49 degrees.